G25, let's go. Statistic, yeah. Statistic, yeah. Statistic, yeah. Statistic, yeah. Miss Long Hair, Miss Long Hair, Miss Long Hair, Miss Long Hair. Statistic, yeah. Statistic, yeah. Statistic, yeah. Statistic, yeah. Miss Long Hair, Miss Long Hair, Miss Long Hair, Miss Long Hair. Look at me, it's Timmy G. I'm the hitter with the ZTST. Next to a problem, let us see the probability you see me on TV. 1,000,000,000,000,000%. I'm a statistical wonder, a statistical gem. 1 in a zillion, faster than a million. Fruity colors on these numbers, call it a chameleon. Statistic, yeah. Statistic, yeah. Statistic, yeah. Statistic, yeah. Miss Long Hair, Miss Long Hair, Miss Long Hair, Miss Long Hair. Statistic, yeah. Statistic, yeah. Statistic, yeah. Statistic, yeah. Miss Long Hair, Miss Long Hair, Miss Long Hair, Miss Long Hair. Everywhere that you point is the best. Take a look at my face, do a guy sweat test. Better than the rest. Catch me on the cable. I got girls equal to the random digits table. I got rap bars, I got X bars, I got fat cars, I got superstar. I'm eating checks, bitches. Queers being rude, Jake's being rude. I'm a deck. Statistics. Miss Long. No, let's go. No, mean show. Let's go. We love you. No, let's go. We love you. We love you. Miss Long, yeah, she's my favorite teacher ever. Favorite teacher ever. Teacher. And I got boy, little Timmy Tell. What a statistics class coming through loud. G25. Yeah. Live G25. Let's go. Statistic, yeah. Statistic, yeah. Statistic, yeah. Statistic, yeah. Miss Long Hair, Miss Long Hair, Miss Long Hair, Miss Long Hair. Statistic, yeah. Statistic, yeah. Statistic, yeah. Statistic, yeah. Miss Long Hair, Miss Long Hair, Miss Long Hair, Miss Long Hair. Look at me, it's Timmy G. About to hit him with the ZTST. Next to a problem, let us see the probability you see me on TV. 1,000,000,000,000,000%. I'm a statistical wonder, a statistical gem. 1 in a zillion, faster than a million. Fruity colors on these numbers, call it a chameleon. Statistic, yeah. Statistic, yeah. Statistic, yeah. Statistic, yeah. Miss Long Hair, Miss Long Hair, Miss Long Hair, Miss Long Hair. Statistic, yeah. Statistic, yeah. Statistic, yeah. Statistic, yeah. Miss Long Hair, Miss Long Hair, Miss Long Hair, Miss Long Hair. Everywhere that you point is the best. Take a look at my face, do a guy sweat test. Better than the rest. Catch me on the cable. I got girls equal to the random digits table. I got rap bars, I got X bars, I got fat cars, I got superstar. I'm eating checks, bitches. Queers being rude, Jake's being rude. I'm a deck. Statistics. Miss Long Hair, Miss Long Hair. Statistics. Let's go. Shout out Miss Long. I'm like, no means no. Let's go. No means shout out. Let's go. We love you. We love you. We love you. We love you. Miss Long, yeah, she's my favorite teacher ever. Favorite teacher ever. Favorite teacher ever. And I got What if statistics class? I'm coming through live with G25. Yeah, live G25. Let's go. Statistic, yep. Statistic, yep. Statistic, yep. Statistic, yep. It's lockdown. It's lockdown. It's lockdown. It's lockdown. Statistic, yep. Statistic, yep. Statistic, yep. Statistic, yep. It's lockdown. It's lockdown. It's lockdown. It's lockdown. Look at me. About to hit him with this GT. Next to a problem, let us see. The rubber prison till you see me on TV. 1,000,000,000,000,000%. I'm a statistical wonder, a statistical gem. One in a zillion, faster than a billion. Fruity colors, all these numbers, call it a chameleon. Statistics, yeah. Statistics, yeah. Statistics, yeah. Statistics, yeah. It's lockdown, it's lockdown, it's lockdown, it's lockdown. Statistics, yeah. Statistics, yeah. Statistics, yeah. Statistics, yeah. It's lockdown, it's lockdown, it's lockdown, it's lockdown. Proof everywhere that you boy is the best. Take a look at my face, Joy Cosquare. Better than the rest. Catch me on the cable. That girl equal to the random nigga get the table. That's like 40. I got rap bars, I got X bars, I got back cards, I got superstar. I'm making checks fix. Queers being rude, Jake's being rude. I'm a deck go. Statistics. Miss Law and all, Miss Law and all.
Okay, everybody, welcome to my class. I apologize for being late because of there was a sound issue in my computer, and that's why I'm a bit late. So let's start now. So today's topic is about cumulative frequency and box and whisker plot. So let's suppose that for the let's see this data. So this problem states that the vertical line graph shows the number of goals scored in a match by Jamima in the 24 games last session. And this is the graph. You can read off the values from graph. So along the x-axis, you can see that this is the number of goals scored in a match. So like this, and then along for the value of x, that is number of goals scored in match. You can take this as x values, and towards the vertical axis, these are the frequencies. You can take that as the frequency value. So first of all, we develop the table for that. So here in this case, what I'm going to first discuss about that most of you already know, although I'm going to revise the same thing again. So from this graph, you can see that x value and there is f value, and the topic is cumulative frequency for discrete data. So we are talking about discrete data. So this is not the continuous data, even though if you have looked at this line graph, so line graphs are for the discrete set of frequency distribution. So here my values of x's are 0, 1, 2, 3, 4. So I'll write here 0, 1, 2, and then I'll make table like this. And then frequency for 0 from the graph, you can see that this is 3. I don't know how this picture from the book is clear to your screen, but I'm doing from the Nelson Mathematics S1 book, and this is from page number 47. So you can check it back if you don't find this picture is clear on the screen. So if you read up this value, so its value is going to be 1, 2, 3. So it has frequency 3. So here, fortunately, the graph means along the y-axis. If you suppose, then 1 unit is each a small square. The length of each small square is 1 unit here. along the y-axis. So up to here, this is 1. So it contains, 1 contains how many? 1, 2, 3, 4, 5. So 5 units along the y-axis is counted as 1 here. So it is 1, 2, and 3. So its frequency is 3. If you check the frequency for that, this is 1, 2, 3, 4, 5. And you can see here also it is, its height is 5. So you can write here 5. And then frequency for another, this class is for whose x value is 2 is 7. And then for 3, the frequency is 5 again. And then for the, and for 4, the frequency is 4. All right. So let's check again. This is 3, and then 5, and then 7, and then 5, and then 4. 4. And this question, if that would be here, then just by observation, we could say that the median is 2 in this case. But even though it is very near to the symmetric curve, so it looks like the median value is 2. But in this case, let's calculate it, because it says that find the median number of goals. So in order to find the median number of goals, first here you can develop another table to x, and this is the CF, so frequency. So which values are here? Less than x means we can see here 0, then less than 1, then less than 2, then less than 3, then less than 4, and go like this. Better you use a scale and pencil to draw this table, then it looks nice. You can see that up to 0, that means if you talk about less or equal to x means this value is like less or equals to 0. And here for 1, this is less or equals to 1. That includes 0 also. Here it is less or equal, keep on adding. So here you can see here less or equal to 3. That means up to 0, up to 3, then up to 0 is frequency 3. So we have nothing less than that other value. So we write 3. Now less or equal to 3 value means we have to include this 2. So in this 2, if you add this 2 frequency, it's going to be 3 plus 5 as 8. And then similarly, less or equals to 2, less or equal to 2 means you can add all this 7, 5, 3. So 2 and below, all the values should be added in the frequency. So in this value, if you have already added up to 5, so just you add 7 and it's going to be 15. And then this is 5, then it is 20, then this is 4, then it is 24. So total frequency in this case is 24. So this is the way that we find the cumulative frequency. Now the question says that by using this cumulative frequency, you have to find the median. So it helps you in finding the median is equals to n plus 1 by truth item in general. So this is a criteria to find median, because median lies exactly at the center. So we have to find the central value, mid value from this. So here in this case, the value of n is, you can see that total n is 24. So we write here 24, and then plus 1 divided by truth item or value also you can write. That means it is 24 plus 1 is 25 divided by 2 is 12.5. So 12.5th value. And your 12.5th value is, if you say, that means this 12.5, it lies here in 15. And the corresponding value of x in this case is 2. And this is the mid value for this set of data. And therefore, your median value is now here 2, and this is the answer. And in another question, it says that find the interquartile range. Interquartile range means you have to find Q3 and Q1 first of all. So let's find Q1. So Q1 you can just find by observation also, because this is the median position. So Q1 value must be less than 2 or between plus 1 by 4th item. So if you write n plus 1 by 4th item means 24 25 by 4. So 25 by 4 is 25 divided by 4 is, it is 6.25. So it is 6.2 fifth values. Now let's check where does it lie in the cumulative frequency. So 6.25 lies here in 8 and its corresponding value is 1. Therefore, the first quartile value is 1. And similarly, Q3, just to write 3 times of n plus 1. That means you just multiply 6.25 by 3 here, or another way is that you take the median value and then take median of another upper half. That will also give you the value of the third quartile, that is the upper quartile. So here, this is 25% and upper quartile is 75%. So you have to multiply with 3 times of 6.25, 6.25, and that is 18.75. You can see here 18.75. So let's write here 18.7 fifth value, and this value is 18.75 lies here. It lies here. So the Q3 value is 3. So you can write here 3. But according to your question, it says that to find the interquartile range means, therefore, interquartile range, all of you know that this is Q3 minus Q1, and Q3 value is 3 minus, and your Q1 value 1 is 2, and this is the answer. All right. So median we have got is 2 over here. So this is 2. Okay. So in this way we find cumulative frequency from we can develop cumulative frequency from the given set of discrete frequency distribution, and from this sort of thing we are able to find median, quartile, first quartile and second quartiles, and hence the interquartile range. So objective of finding interquartile range is to find among the, what is the middle 50% of the data, what is the variability in the middle 50% of the data. So we can say that it is 2. Okay. Next, you can see here, this is about cumulative frequency for grouped or continuous set of data. And also later on, we'll discuss about box and whisker plot. That is the box and whisker diagram also, you can say. You can say also diagram. All right. So let's see how to find it. So first of all, I'm taking the class interval like 0 to 5, 5 to 10. At this time I'm taking the equal class interval 10 to 15 and 15 to 20, and F is, say anything like this is 11, this is 9, this is 8, this is 10, for example. And in this case you have to develop the cumulative frequency first of all. So definitely this is a continuous series. This is a continuous series, and let's see how we find the cumulative frequency. So let's develop a table like this. You can develop the table horizontally also, but at this time I'm writing in vertical form. And here you can make a column of frequency if you like. Make a column of frequency, then you can write column of CF means cumulative frequency, and we are working for here continuous set of data. So here in this case, okay, you can go like this. So this should be X, and here it should be CF. So X I will define after writing all these values. So I'm writing here 0 to 5, then 5 to 10, 10 to 15, and then 15 to 20, and the frequencies are 11, 9, 8, and 10. Now I have written that X so less or equals to X, less or equal to X. So for example, if I talk about less or equal to 0, if I write 0 over here, that means what? We are looking for the values less or equals to 0. And if I write here 5, for example, then I am looking for the values less or equals to 5. How many are less or equal to 5? So you can say that it starts from 0 to 11. So less or equal to 0, there is no value. So CF is 0 in this case. So CF for that is 0. And less or equal to 5, if you say, then it also includes 0, and that frequency is already here 11. If you say less or equals to 5, then another boundary is 10, and then we have 15, then we have 20. That means we are talking of less or equals to 10, less or equals to 15, and less or equals to 20. That means what? Now, if you talk about less or equals to 10, that means we are that includes also the values less or equals to 5 and less or equal to 0 all. So what we can do in this case, at the frequency for this class is less or equal to 0 is 0, less or equal to 5 is 9, less or equal to 10 is 8 plus 9. You can write 8 plus 9, and this is 15. And less or equal to 15 means it also includes less or equal to 10, less or equal to 5, less or equal to 0. So we add 10 over here. So if you add 10 over here, so 15 plus 10 is going to be 25. And less or equal to 20 means that is also less or equals to 15. So what we did actually, for less or equal to 0, that value is 0. Less or equal to 5, we have 11. Less or equals to 10, we have, here. Less of is 5, 11. Less or equals to 5 is 11. Less or equal to 10 is 11 plus 9. Sorry, it should be 11 plus 9 is now 20. And less or equals to 10 is, you have to add plus 8, so it's going to be 28. So it is 0, 0 plus, now we have to write it again. So this value is 0, and 0 plus 11 for another value, it is 0 plus 11. For 5, for 10, it is 0 plus 11 plus less or equal to 15 means 9 plus 11. Less equal to 5 means less equal to 0. Less or equal to 5 means 0 plus 11. Less or equals to 5. Less or equal to 10. Less or equal to 10 means we have here 9 and 11. So plus 9. Okay, less or equal to 10 is. Less or equals to 15, you can see here 15 less or equal to 15, then it is 0 plus 11 plus 9 plus 8. We have to check here. Okay, and 15 we are done with. 8, and now less or equals to 20, we can write 0 plus 11 plus 9 plus 8 plus, you can see here less or equal to 20 is 10. Let's check what is the total value. This is 30, and this is 20. It's going to be, total value is 50 over here. So let's check here. You can add this value. This is going to be 11 plus 9 plus 8 plus 10 so we are missing out one value over here. So for this it is 0, and for this it is 0 plus 11, okay, then plus 9, then plus 8. So it is, sorry, 11 plus 9 is 20, 28 and 38. So total value is here, total F is 38. And let's check that also. It is 11 plus 9 plus 8 plus 10. This is 38. Okay. So this is 38 and this value is 20. Then this is 28 and then this is 20 and this is 11 and this is 0. So this is the given set of data and we want to find the cumulative frequency. So first of all, we start with this boundary 0. So less or equal to 0 has no frequency, we write here 0. But less or equal to 5 has frequency 11. So we write here 0 plus 11. And then less or equal to 10 has 5 to 10 has frequency 9. But if you say less or equal to 10, then it still includes the value less or equal to 5. So less equal to 5 value means in 11 you can add this frequency 9 and keep on adding this frequency, and so that we have cumulated that, and hence as we have cumulated this value one after one by one, we have added the value one after another, then this sort of adding of frequency is called the cumulative frequency. So in this case also you can find the median class if you like. So median class means in this case, if you would like to find median class, for example, that means you have to write n by 2, and n by 2 means 38 by 38. So this value 19 lies in the CF value 20 and its corresponding class is this. So your median class is, in fact, it is 10 to 15. So 20 for this and this is 10 to 15. All right. So in this way you can find median class. Now if you have look at this table, this is only a group frequency distribution. So in order to find cumulative frequency, then first of all you have to convert that into continuous class interval, continuous class boundaries first of all, and then you have to proceed as you have seen it just now. So in this case, let's see. First of all, let's read this question. Okay. The question states that a factory produces certain components. In a quality control test, 500 components were weighted and their weights recorded to the nearest gram. The table shows the results like this. You can see here the weights are in gram, so it's from 60 to 69 gram. The frequency is 30, and 70 to 74. The frequency is 90. And also, if you can have look at here, so total frequency is 500 here. Let's check whether or not this is 500. So here it is 30 plus 90 plus 130 plus 210, 210 plus it is 40, then 40, and then this is 500. You can see here 500. Okay, so that we have copied it correctly. Now it says that construct a cumulative frequency table and draw a cumulative frequency graph. So in order to draw the cumulative frequency table, we have to do the similar work that we have done. But first of all, you will have to convert that into the class boundaries. So first of all, when you convert that into the class boundaries, then what happens? Okay, Avanis, I can see the comment here. Please reply, sir. Big fan, Avanis. SK, nice, nice. I think this is only benefit of coronavirus dream come true. Thank you so much for your comments, everybody. Aditya, Avanis again, and then last one. Yes, then Savin Baral. I think this is only benefit of coronavirus dream come true. All right. So here, actually, I was supposed to start at 4:15, and I tried one software, and my laptop wasn't able to hold the load of that software this time. I think there is some problem in my laptop, or the internet quality is not that good. That's why I'm having this sort of problem here. But anyway, I've been trying my best to make it clear to you all. Thank you so much to you all for your comments. Thank you so very much. So let's continue from here now. So at this time, what I'm going to do is that a factory producer, that means this is a sort of problem from the cumulative frequency graph, cumulative frequency distribution. And here in this case, we have to see that how we construct the cumulative frequency for this sort of group data. Previously, it was continuous set of data I had taken here. And for this, there was no problem. We could do it directly, but here, we have to just first of all find the class boundaries. So in order to find the class boundaries, so I'll do a little work here. So X value and another value as F I will keep here, or let me as X, and another, the frequency is there. So first of all, what I'll do actually, you know that you deduct 0.5 from the lower limit and add 0.5 to the upper limit, then it's going to be 59.5 to 69.5. And another class will be, you deduct 0.5 from the lower limit, then it's going to be 69.5 to 74.5, and then we have 74.5 to, it is 79.5. So we have added 0.5, subtracted 0.5 from the lower limit, and we are adding 0.5 to the upper limit. And then I have, I'm here now, so it is 79.5 to 84.5. Okay. And then lastly, I have, it's hidden on the camera, I think. Yes, it's okay now. So for this class interval, lastly, we have 85 to 89. So it is 84.5 to 89.5. So look at this thing here. So lowest bound is 59.5 and the highest bound is 89.5, and our frequency is 30, 90, 130, 210, and for that class interval it is 40. So altogether this is 500. All right, so I don't think that you can see. Okay, let me turn like this. Yes, so I have just I did nothing, but I only converted this group data into the continuous set of data. And based on this, what I'll do now, I'll develop a table for less than equal less than x or less or equal to x, don't matter, but it should be less than x. Okay, because upper limit is not included here. So make correction in my previous thing. It should be, where is it? It should be less than 0, less than 5, less than this. Why? Because upper limit will not be counted here. That's why. So meaning of this is x is less than 5, greater equals to 0. And this is the reason why we write less than. So it should be less than, sorry. But it doesn't matter. Your mark is not going to be deducted even if you write less or equal to here. It doesn't matter because these are at very boundary point. And for the continuous data, the boundary point doesn't count a lot. Okay. And now I'll write here CF. So this is the column for CF. So in order to do that, what I will have actually here, less than 59.5, then another for less than 59.5, or another for less than 69.5. So all are in less than, you remember. And then it is 74.5, and then it is 79.5. What are we left with then? 84.5, and then we have 89.5 lastly, 89.5. So lastly we check here, it is 89.5. And the way I did was only in order to show you that this is the process to do, but you don't need to write this sort of a step. You can directly write here like this once you become used to of this. But in the beginning, I'll suggest you to do the work in detail, so that you'll be able to see each and every thing about that problem solving strategy. And then let's see here for less than, even if you consider for a while this is your suppose that this is this sort of class interval continuous, then less than 60, look at here, greater than 60 to 69, we have 30. So less than 69 is 30, but less than 60 is nothing. That will be 0. After adjusting the boundary to the continuous, it is less than 69.5. So altogether there is 30 value. And then another we have 74.5. So we have already talked about less than 69.5. Then it is also 7. That means in the adjusted class interval, it is the boundary is 74.5. So less than 74.5 is 90 plus 30, and this is going to be 120. And similarly, you can add up like that. Then it is going to be 250, and then it is going to be 460, and plus 40 is going to be, it is 500. So in this way, our CF table, and then we have done only half work in this problem. It's that to draw a cumulative frequency graph as well. So in order to draw the graph, you require x coordinate and the y coordinate, and now we have all this xy value over here. So you suppose x less or equal to x value as x coordinate, and this is as y coordinate in each pair of value, and then you can draw a graph. So I have got the graph of it ready. So what you can do here, I have kept the dark line, although, but better you use pencil only when you are practicing here. So I have used dark line in order to make this clear into the camera. Okay, so let's see here now. Let's take a pencil, but I'm taking pen. So less or equal to 0.5 value, and this should be 0. So you can cross mark like this. And then it is 69.5 is 30. So in order to do that, first of all, let's see here that how we have scaled the graph. You don't need to write actually, but in the beginning I'll say in your problem area in your examinations. But the things should be such that you can read off the value as it is required by the given problem. So here in this case, So this frequency is 0. So let's see here. 2 units along x-axis equal to 1. So 2 unit means 2 a small unit I have counted as 1. So let's check here. 1, 2, 3. So it is 0, 1, 2, 3, 4. So I'm taking the difference of 4 here. So here also the difference of how many? 1, 2, 3, 4. Difference of 4. Let's see. So 2 units along x is 1. So in this case, and also at this point, this is origin point, and because our starting is from here, you can give some broken line also like this if you like to, because in order to say there is another value. Okay. So 2 units means I have counted a small 2 units here. It's okay. So up to here is, let's see here, up to here is 1, 2, 3, 4, 5. That means it is not 5, it is 2.5. And this is another 2.5. That is 5. And then this is another 2.5, 7.5. This is another 2.5, 10. So difference between these are supposed to be 10. Okay, so these line parts are actually for the 59.5, not for the 59 or 60. So I have taken the reference like this. So this is up to us that how we make our work easy. Okay, so this is CF we have plotted along the y-axis. So this is the scaling I have done here. Look at here, up to here, about the origin, I have written nothing here, and here is 100. That means at this point it is going to be 50. All right. So each small thing, a small square has a height. How much it is then? Up to here is 50, and there are how many squares? 1, 2, 3, 4, 5, 10. It's okay. So as there was for the 10 small square, there is count of 50. Up to here, this is 50. There is count of 50. Then for one small square, by using the unity method, this is 50 by 10. That is going to be 5. So in the small thing, if you count 1, that means you are counting up to 5. This is 50, and one step up if you go, that will be 55. Then another step if you go, that will be 60, and like this. So this is up to you that how you grade your graph over here, to make your work easy. All right. And although even I have written the along the x-axis, I have written the scale. Along the y-axis, you can write the scale like this. Okay. But even if you don't write, it doesn't matter. But it should be at your understanding. Okay. So 59.59.5 has frequency 0. 69.5 has frequency 30. So let's check 69.5. 69.5 has frequency 30. So up to here, look at here. 1, 2, 3, 4, 5. So 5 is 25. One step up. So this is the point. You can mark cross line also at this point. Okay. And then I have 74.5 to 120. So it is somewhere in between. 69.5, it is here. Okay. So this point is 74.5. Based on how we have scaled here, you can check it yourself as well. And you can see that 74.5 has frequency 120. So where is 120? Let's go up here. No, not very up. It is here. So from here to here, if I'm going 25 unit off, but we require what? 20 only. So this is 100 and 120. That my another point is here. Okay. Now 79.5 has frequency 250. So it's easy. So where is 250? Up to here is 200, and up to here is, yes, this is 250. And then I have 84.5. So I can see that 84.5 is somewhere here, just in between these two, according to this scale. You might not be able to see this scale. I have written 2 units along x is 1. 2 units means not the big units, very small unit. And I have not made it that clear to the camera because you don't need to write it. This is just in order to let you understand. So we have worked up to 84.5, and then lastly 89. Okay, we have not worked for that. So 84.5 has frequency 460. Let's go up. 460. 460 means it is 400 here, and 425, 400, 50 over here, 2 unit, 2 small units of here. Okay, so I have got for that. And lastly, it is 89.5 as means less than 89.5 has cumulative frequency 500. It should be 500, otherwise our calculation will not be reliable. And another point is here at the 500, you can see here. Okay, so let me highlight. It is 100, it is 200, it is 300, it is 400, this is 500, and this is 600, and here it is. Here you can read off. Now what you can do, actually take a scale, don't try to make it curve directly, just join these 2 points. So let me join these 2 points, keep it nicely. You do as nice, if you do it nicely, your value, your estimate will be accurate. But usually we can't find the accurate estimate in the graph because of the eyesight error. There are other sort of error also, but nearby answer works for that, this kind of problem. And then we meet this by a straight line. Note that we meet by a straight line. Then this is using a straight line. I don't think that my figure is correct, but you may keep on trying to do that. Okay, no problem if it goes like this. So this is called the cumulative frequency curve, because along the x-axis we have taken CF, along the x-axis we have taken the values of class boundaries, and along the y-axis we have taken the value of CF. This is therefore this is called the cumulative frequency curve, or in general I'll say graph, because this is a graph of cumulative frequency, so that we can say that it as graph. All right, and look at here, I drawn the straight line, but I'm saying that this is the curve. How it is possible? Look at here, we are given only few points, that's why 9.5, say like say 1000, like say 3000, then will be broken straight line, they join each other, and when the broken straight line, when they join each other, then our eyesight looks it like curves the straight line inside if you do the microscopic study. But logic is that this is the main method that we join by the straight line. But if you consider between these 2 points, thousands, hundreds and thousands of points, what happens? You'll have line like this, like this, like this, like this. So all are straight, although it looks like curve. It's okay. So therefore we can say that this is the frequency curve. So we have drawn the frequency curve. Okay, let's go to the another part of the same question. So this is the table in general, even though we have read this or not, but main thing is here. So construct a cumulative frequency table, we have done that, and draw a cumulative frequency graph, that also we have done. Now what it is telling you, that components, usually in statistics, what happens, there is very long lengthy language written, and usually those languages, okay, actually sounds looming of kind of thing, isn't it? But that should not be our concern. Our concern is to be focused on the main point over here. Whatever name has been given, it doesn't matter. So don't go to the length of the language, go to the main. It states that up to here I can see. Okay, camera position is fine. Okay, so I have taken from the page number. If you can't see it, you can go to the page number 49. So page is page 4950. Okay, I've taken from that. So if you can't see, then you can turn that page also. Otherwise, just see here. Components that weigh less than 64.5 grams or more than 87.5 grams were rejected. Use your graph to estimate the percentage of components that were accepted. So here it says the story that why did we study to know to draw the cumulative frequency graph and also to construct the cumulative frequency table. So there should be application of that. So this is the application. So let's see on this value less than 64.5. So less than 64.5, let's search here. Look at here. If you go to your graph, you have a scale is nicely. Your 64.5 is here. I think I'm highlighting here. So that point is 64.5. All right. Then how to read off the CF of this boundary? You take a scale like this. It's very small. You don't need to take the scale and draw the line. Let's let it to go up on here. So main line is that where it is dark, and then here you require a scale. So at this point, I'm telling you very pretty detail of the process, but when you become used to of that would be easy at that point. And then we read off this value. I think it is going one step down or two step down from here. I think I have done a bit of error, but it doesn't matter. Depends on our eyesight also. So this value, if you read up here, look at here, what I can read, 1, 2, 3 step up. Okay, 3 step, each step is 5, so 3 step up is 15. So my this value of CF is going to be 15. Okay, so I'm noting it down, 15. Okay, now next it states that or more than 87.5. So let's check more than 87.5. So this is 89.5, this is 84.5. So in between there is somewhere it is 87.5. So let me highlight this value for you. What I have written here, I have written here 87.5. Why? Because this question said that more than 87.5. So from this point, this is 89.5. Yes, so 87.5 should be here. 2 step before that. It should be 1, 2 step here because the 89.5. Go 2 step here, another 2, then it will be here somewhere. Sorry, you have to check it. And it seems a bit difficult that way it will meet. You have to check this value, and it goes like this. Do it nicely, and also draw dotted line or a straight line using the pencil. It doesn't matter. And it seems like here it is. So my eyesight is not that good actually, but it doesn't matter if you make mistake of one step up, one step less. It doesn't matter. So this value I can read of is going to be 485 over here. So this value is 485. So this value is 485. Okay, so we have got two values. So what it says that actually, now let's see in the question nicely here that components that weights less than 87.5 grams were rejected. Okay, less than 64.5 grams. So less than 54.5 grams means, so down to here these values are rejected. So these values are rejected down from this 15. Or more than 87.5 grams were also rejected. So more than 87.5. So this point, so about upper this value, if you call about more than that value of CF and along with 87.5, these are rejected. Then what is accepted actually? For you can write here that therefore, let me take another pen. Therefore, number of satisfactory components. So we reject out of this and then down to 15. So this difference is what? So this value is from 0 to 485. So this value is 85 and down to 15 we have to reject that. So we deduct 15. Okay. So it is going to, if you deduct 15, so that is going to be 400. How much it is? 400. 15 or 470. That means now the question is telling you to find in percentage. That means 64 point or this are rejected, were rejected. Use your graph to estimate the percentage of components that were accepted. So therefore percentage of accepted components is going to be, how many are accepted actually? 470 were accepted. Okay, 470 were accepted. Out of how many? Total is 500. So last final CF is, our final CF is 500, you can see. So 470 divided by 500 times 100, and then take a calculator. This is 470 divided by 500 is 94%. So this value is 94%. That means 94% of the components were accepted. It's okay. So in this way we can apply the concept of cumulative frequency table as well as its graph also. So it was about the cumulative frequency. Okay, Sojanya, great work, sir. Thank you for that. But give me comment about the error also, because I know that there is a bit of error because I couldn't fix in the way that I wanted. So that's why I'm taking just simple way. I have annexed my camera to the YouTube in place of my face video, and then I've been doing this. It's okay. So listen now. So here, if you just learn that cumulative, what is cumulative frequency, how to obtain it, that only doesn't work. We have to understand what is the application of the thing that we have learned here. Now, what other thing I can tell you that, like, let me take the replica of this graph. This graph might take a bit time to do, but in this case, let me tell you the further use of this. Our graph is something like this, and the maximum point was 500 here. Okay, I'm taking just, it is broken line, it is 0, it is X, and this is Y. It's okay. So what we have done actually, our work is over for this problem. But what further thing you can see from here? So for example, if I'm telling you to find the quartile, for example, it's okay, or median, for example. So you can see here, median equals to n by 2. So in discrete, we use n plus 1 by 2, here n by 2. That tooth item, yes. And then it is 500 because total n is 500 divided by 2. And then this is 250. So 250 is somewhere in the middle, somewhere here. What you can do here, 250, for example, it is 250 is here. Then what can you say about the median? So in order to find the median, what you can do, so 250th item you have to find, then we have to look in CF value, where is 250 or what it is there. So we look at this CF value 250, and this is the value of X. And then what we do, you draw a line horizontal to the X-axis, or good idea is that you take a vertical line from Y-axis and cross this curve, and then take your scale, drop down to y-axis nicely. As you go nicely, your value will be more accurate. And this rid of this value. Okay, so what we have to do, rid of this value. Rid of this value means this value will be the value of median. So from this graph, can you try reading of the value of median? Let's check here. 250 is somewhere here, and you have to use the scale. If you will go to there, and my median value looks like yes, 79.5. Okay, maybe a bit less or more, but I can see here it is 79.5. So what is the strategy actually? Our CF for median was 250, so I read off here 250. Then I went straight away from here, parallel to y-axis, and where it touches the curve, then I drop down vertically to the x-axis, and I read off this value. Okay, so my median value seems like it is 79.5. 79.5. It might be a bit less or more because we can estimate here, and there is a lot of dependency thing. And similarly, for example, if you want to find Q1, Q1 is what? N by 4. So it is 500 by 4 is 125th item. So 1, 2, up to here it was 100. And each part is 25, so 125 is somewhere here, I think. Yes, then you do the similar work, you go like this, and drop down to here. So that will be the value of Q1. So let's read off the value of Q1 from here. It should be at 125. So let me check, where is 125? Yes, this is 100, and there is difference of 25. So it is, because each unit is 5, so 125 is here. I hope you can see it. And then take a scale nicely. So I'm dropping at this point. From that point, it is a bit ahead. Yes, it is near to 74.5. It looks like 76.5 for me. So, okay. So is in fact, quartile 1 value is 74.5. So let me use another color. 74.5. What about the third quartile? Third quartile simply 3 times of 125. So this is going to be 375th item. 375 means up to here 200, and then 300, for example, here. But you require 375, so 350 and 375 is somewhere here. You have to see it nicely. So 375, and from this part I will draw the line parallel to the y-axis, and I will drop it down like this. Okay, and that will be the value of Q3. So from our original graph, can you estimate the value of Q3 here? It was 375, so it is near to 400, and at this point it is 375. It's okay. Yes, 125 times 3 is 375. Okay, and now I'll take the scale and I'll go through the line parallel to the x-axis, vertical to the y-axis, until it touches the CF curve. So it's somewhere here. Okay, and from here I can drop down a bit like this value. Yes, it is 79.1. It looks like 79 plus 2 is 81. It looks like 81. Okay, so my 81 value, where it should be? Yes, so here Q3 value. Yes, Q3 is already here. So Q3 value is 81.5. Okay, now let's see what we do by finding the quartiles from here. One benefit is that I think I need one music for you here, and I'll bring the graph paper from another room.
Shout out Miss Lauren. I'm like, no. Hey man, it's your boy Little Timmy Town.
I'm going to
Everywhere that you boy is the best. Take a look at my face, do a cock sweat chest. Better than the rest. Catch me on the cable, girl equal to the random
okay, guys, from this graph, or let me draw the graph nicely. So I'm just taking the model of graph. It was 500 0, and the minimum was, yes, it is 59.5. So let's see here. I hope you understood how to find the value of quartiles and medians. So divide total, that means last year, by 2, then you'll get median. So that value was 250, and then I moved horizontally about this point, and when I reached to this, and that value of x was median. Why? Because I am taking this value based on n by 2. Okay, so there were 250th value. And similar work I did for q1 by n by 4 and q3 by 3 times of n by 4, and I did the same work. And my median value was like this. So let's write the main value. So quartile is 74.5. So quartile is, for example, say quartile was here, it is 74.5. So here now, this graph is not to the scale. To the scale graph was here, but I'm just noting down the value of quartiles and median. And median was, how much it was? 79.5. Yes, median was. You can see here, median value was 79.5. And then you see here, third quartile was 81.5. 79 and 81.5 is, suppose it is 81.5 is somewhere here. So this is to the scale, but this is not to the scale, but you have to find this information based on the graph which you drawn to the scale. So note it down. Okay. But what is the objective to do this? Objective to do this, that this is the Q1 value, this is the Q2 value, that is median, and this is the Q3 value. And here also note it down, its maximum value was, with the main graph, yes, its maximum value was 89.5. So note down the 89.5 is somewhere here, 89.5. So what is this actually? This is the minimum value, this is the maximum value in our data, and this is the quartile value with that we derive from the graph, this cumulative graph. Okay, so let's check here, and these are 3 quartiles. Let's check here. Let's cut it out. Suppose that we are cutting it out and sliding it down. Then what happened? For example, suppose that your 59.5 is here, and then your Q1 value I am taking here. Yes, your Q1 value is 74.5. Q2 value, Q1 value is, and Q2 value is somewhere here. It is, how much it is? 79.5, and your Q3 value is somewhere here. So here at this point, this is not to the scale, but you can draw this to the scale if you use your original graph. But why I'm not doing here? Because I have written a lot of things, and that will confuse you. That's why I'm taking just model of this graph over here. But what I'm going to do is important. So what is this actually? This is the minimum value, this is the value for Q1, and this is the value for Q2, and this is the value for Q3. What are we left with now? Yes, 89.5 is here. So this is 89.5, and this is the maximum value. This is the maximum value. Now, can you consider a box using all this information? For example, let's see, I'm considering a box like this, like this. Look at here. This line is for Q1. This middle line is for median, that is Q2. And this line is for Q3, that is the upper quartile. I am taking middle, I'm joining this. And for this maximum value also, I am joining this. So look at here what it contains. It contains box and these two lines. So this box is called box diagram. All right. And this sort of tail you can see here. So these tails are called whisker diagram. Box and whisker diagram. That is called box and whisker diagram. I hope you understood how we develop the box and whisker diagram. So from cumulative frequency itself, we are able to develop the cumulative frequency table. Then we are able to draw the graph. That means we develop the scale only, the idea only. But what did we get by learning this sort of thing? We are able to find the information that was asked in the question, and that information was that how many percentage of the components were accepted based on the given information. You can see graph was applicable to there. And not only that, you can find median quartiles. So a lot of things that we can calculate from, we can estimate from this graph. So at this time, we'll do for other sort of information like this, which are given in your problem area. And then we'll see, we have seen that how to find all the quartiles. That is first quartile, second quartile as median, and the third quartile as, that is the upper quartile. So by taking all these reference 1, 2, 3, and then minimum and maximum value, and this is actually what? 5 set data. So what are the 5 set data that we drawn out from this? 5 set data are Q1, Q2, Q3, and minimum and maximum values. So based on this 5 set of data, okay, we can draw box and whisker diagram. But still, this is not just like a painting or making a figure. It has also some meaning here. So in the box and whisker diagram, I don't know how it is because I am taking this not to a scale. So when you draw your box and whisker diagram from the scale, you will have the real picture of that, but it will look like this. So here you can see that both gapping from Q1 to Q3 and Q2 to Q3, they look same, or you can calculate it if they are same, for example. Then in that case, what you can say, the data is symmetric. That means the data is from, sometimes also you can say the data is from normal population, that is symmetric. Then what happens in some box and whisker diagram, you'll see something like that. This is Q1 position, this is Q2 position, another line is, and this is Q3 position. You can see that gap, and this is between Q2 and Q3. Okay, you'll obtain your box and whisker like this. Sometimes it is also possible that your box and whisker will be like this. And it is minimum, it is maximum, it is Q1, Q2, and Q3. So what you have seen, that gap to the left is more here. So what can you deduce from this sort of diagram? If you find diagram like this, you can say that there is few more values towards right side. That means the data is positively skewed. It goes to the right side, more gapping from Q2, it is positively skewed. Now the values are more to the left side, that means the variability is more to the left side. So it tests the variability of the data, and this sort of thing will be called the negatively skewed. Diagram is something like this. It is minimum value, it is maximum value. Can you see it clearly? Okay. And this is Q1, and in between this is Q2, and here it is Q3. You can see that the gap is almost equal, or as this is the graph, you can say that these two gaps are nearly equal. That means equal. Symmetrical data means what? You can say that the data is, or the values are okay, the data are, or the values are, data is plural itself, evenly distributed. Therefore it is symmetrical data. Okay. Also, in order to have a good consistency of data, if you find the symmetrical box and whisker diagram, then you can say that the data are evenly distributed, and hence this is better data than other sort of data. Okay. So here it is, variability is more to the left. This is called the negatively skewed data. If you find this sort of diagram, and it is the gapping more to the right, then it is called the positively. So to the right it is positively skewed, and to the left it is negatively skewed. In both the cases, data is more variable. But here in this case, the data are evenly distributed. That means it indicates the good growth rate and the consistency in the distribution of values in the series of thing. But I think it is better that I'll discuss some of the problem here. I'm not going to do that, just I'm going to talk to you. For example, yes. So first of all, you should learn to draw the box and whisker diagram from your cumulative frequency graph. Yes? Okay. So due to the light, I don't think that it is that clear, but you can go to page number 60 and have a look at these figures. Look at here, this is the box and whisker diagram that I have discussed just now. So look at here, if you draw the curve, no, this is not the cumulative frequency curve, it is directly from the frequency. We like this. Look at here, between Q1 and Q2 there is more gapping, and by reference of all these Q and Q3 we have taken the box, and this is the minimum value, this is the maximum value, this is the 5 summary data. This is called the 5 summary data. You can see there is more gap between towards the left, or you can say between the whisker to the left is longer, and the median is near to what? Q3. Yes, so then it is called the negative SQ. So we have to have look at this also. You can see the whisker part is more, elongated to the left, and also median near to the Q3. That means there is more gap to the left. Yes, so that this sort of thing, if you see in a box and whisker diagram, it is negatively skewed. And for the positively skewed, same thing happens here. Towards the right whisker, you can see there is more, its length is bigger than the left one, and also Q2 is near more to the Q1. That means there is gap to more to the right side. It means this sort of variability of data is called the positively skewed data. So both the data have certain degree of variability. Practically all the data, all the series of observation, you will find there is variability in the data. But if they are very near, you can see both sides the equal area, and here also the whiskers are of nearly equal length. In this case, this sort of data, if you find by using the cumulative graph, or otherwise if you draw the box and whisker diagram, and if your diagram is like this, then you can say that the values are uniformly distributed over there, and hence that sort of series of observation will be called the symmetrical observation or symmetrical set of data. Okay, so it was about the box and whisker diagram. Now lastly, I want to discuss one more thing over here that you are very much used to of it. Let me adjust the light. No, it's gone. I think if this light is fine, but it's okay. I'm taking it from page number 61, and you can see here, this is the back-to-back stream plot. So the example states that the following back-to-back stream and leaf diagram shows the cholesterol count for a group of 45 people who exercise daily, and for another group of 63 who do not exercise. To the right side, the people who do not exercise, and to the left side, the data is for the people who exercise. And they are going to measure the cholesterol status of the cholesterol level for the people who do not exercise and who exercise. And this is our information that you are already familiar with, and these are the frequency area, you know. Okay, now give one useful feature of a stream and leaf diagram. I'm sure not only one, you are very much used to of doing this sort of diagram, and you know that. So you can write any one feature of this, finding the stream and leaf diagram. You can easily find mean, median, even mode also, and also you can analyze the variability of data. There are a lot of things that you have done, so you can write one of them. And good idea that how main thing is that how the key has been defined. You can see that here 281. So it says that according to that, 82 means 8.2 and 81 means 8.1. And these are the data for the cholesterol. So 4.3, if you want to read, that means it is 4.3, and 4.5, that means it is 4.5. You can read. So all of you are familiar with this. I know that. And now in the question number 2, just this is a discussion. I'm not going to do anything, but this is based on what we did yesterday. Find the median and quartiles of the cholesterol count for the group who do not exercise. So what it is asking you to do that, not to do anything to the left. At this time you have to find for the right only, that is people who do not exercise. For that information of cholesterol data, you have to find median. So you know median equals to n plus 1 by median is n plus 1 by truth item. All of you know that. 63, if you add up all this, that should be 63. 2, it is 64, means it is 32 item. So 32th item means you can just count 1, 2, 3 up to 32th. Otherwise you can add this. So how it is? It is 23. We need 32. 23, 32 will be here, I think. So up to here is how much it is? 10 and 13, 23. Now 24, 25, 26, 27, 28, 29, 30, 31, 32. It looks like 6.5. Yes, here also, this is from the example work. So here also 5. So 6.5 is the median information for this cholesterol data. And similarly, you can find Q1. So take median of lower half values. So it is now Q1 value is 5.4, and similar work you can do for Q3. Find the median of upper half about this 6.5, then this value is 8.3. So we have now all three information. All three information means here first quartile, second quartile, that is median, and the third quartile as well. Let's see, it has answered this question. Find the median and quartiles of the cholesterol count for the group who do not exercise. So this we did for who do not exercise. Okay, so we have already got that. So our median was 6.5, first quartile 5.4, and the upper quartile was 8.3. What it is asking us to do now, you are given that, let me move a bit to down. Yes, it's fine now. I think. You are given that the lower quartile, median, and upper quartile of the cholesterol count for the group who exercises, means for the data to the left, are this given. We are lucky that these are given. We don't need to calculate. Send Whisker's plot to illustrate the data. 3.1 and the maximum value as 10.3. So by taking all the information, all 5 state data information, what you can do, you take a graph, scale it nicely, and then your graph will be like this. So this is for the people who do not exercise. It's okay. Now similarly, so luckily we are given that all the information from towards the left data, only we have to read of the minimum and maximum value. So your quartiles are given as what it is. Yes, 4.25 Q1, Q3, Q2 is 5.3. That means median 6.6. So what we have to read of? Yes, minimum value is, what is this? 1.3 means what? 1.3 means 3.1 or 1.3. So according to the key, 2.8 means 8.2. Okay, so 2.8 means 8.2. So 1.3 means 3.1. So minimum value is 3.1, and the maximum value, you can see that 10 doesn't exist. It is not even 0. Okay, if that were 0, then that value would exist. There is nothing. So the minimum value is 9.4. So by taking all these 5 set of data, you can draw on the same graph the another box and whisker diagram. Okay, you can do this work. You may practice to do. And then after that, we have to analyze this data. Then what we are going to analyze? You are given that is fine now. Yes. You are given that the lower quartile, median, upper quartile of the cholesterol count for the group who exercise are this. Okay. On a single diagram paper, draw a 2-box and whisker diagram that we have already done. Did it ask us to do anything more than that? No. That means you just draw it and then finish. But what we can get from there, that we can discuss. Look here now. If you have look at this data, it looks like positively skewed, and this looks like nearly symmetrical. That means things have been consistent here and things have been evenly distributed. Although its whisker part to the right is big, it is a little bit variable, but first data is more variable. Then what you can conclude, you can see here, it is also given that use graph paper as that way. So what you can see here, these are given a scale. Yes, you can see here, like people who exercise has minimum value 3.1 and maximum value 9.4 that we have seen, who exercise here on this graph. People who do not exercise then have this maximum minimum information, and then this. So what you can conclude from here is the data is more symmetrical for the people who exercises than who do not exercise. That means the people who do not exercise have, weight distribution. There is heterogeneity in the weight distribution. That is, their weight condition is not good. That is their cholesterol condition is not good. But the cholesterol condition is better in the people who exercise. So let's see how we can apply this to the real life situation as well. Okay, then we'll discuss the same thing again during our class tomorrow. But better you have this sort of thing yourself revised, so that tomorrow's class will be even easy for you. So that is all from my side for now, and then see you tomorrow. If you have any question, then you can write in the comment box. I'll try to answer all questions, not most of the question, but all questions. Okay, thank you for watching, and thanks for the patience as well. Thank you for your patience as well. Bye for now, and good night.